All right, good morning, boys and girls, and welcome back. Here we go with Power Series Part 1B. I got three more questions, examples to finish up with you real fast. So let's look at another Power Series and find its interval of convergence and radius of convergence. So if this is our Power Series, we're going to want to, again, use the ratio test to find the interval of convergence. So when we set up the ratio test, again, we're going to add 1 to all our n's. Okay, so x to the n plus 1 over n plus 1 quantity squared. Then divide by, again, that previous term. So I'm going to divide by x to the n over n squared. But when I divide by that fraction, again, if you want to just one step like I did here, skip, flip, and multiply, that is okay with me. I probably would then even take this thing and now when I simplify it, kind of put some stuff together. And what I mean by that is I'm going to put my n stuff together. So I'd have n squared over n plus 1 squared. And then I put the x stuff together. When I divide these x's, subtract exponents, I'm going to end up with just with x, right? So that's kind of my simplified form right here, and I want to know when this is going to be less than 1. Now, as I look at this as the limit as n goes to infinity, again, those n squares are like basically going to cancel off, and I'm going to end up with just the absolute value of x less than 1, and so I need to solve that, and we're going to get x is less than 1 or x is greater than negative 1, and so there's our interval of convergence. And now we just need to go ahead and test our endpoints. So when we take our power series, we plug in negative 1, I get negative 1 to the n over n squared. And this is an alternating series whose terms go to 0. It passes the nth term test for divergence. And they're getting smaller every time. So this is a converging alternating series. So we would need an or equal to part on the negative 1. All right, now I got to test my other endpoint. And we get 1 to the n over n squared, which is just, 1 over n squared. And 1 over n squared would also converge because of p-series. See, this is where all those tests we talked about earlier on, they're going to come back into play. And we got to, look at these series to test our endpoints to know whether they're going to converge or diverge. And again, so this is a p-series with a p that is bigger than 1. So that is going to converge. And again, here's our part. We can't, really go over questions since we're doing this virtually. But I know, like in the past, some people wonder about, well, what about the first one? Because I said p-series on this up here on when we tested negative 1. And no, because, again, p-series is for only positive term, a series. And, again, this one up here is alternating, so I'd have to use the alternating rule. So that's where they'll get you a little bit to make sure that you really understand, make sure you're applying the right test to the right series. Anyway, in this case, both endpoints converge, so I would need an or equal to on both parts. And our interval of convergence would be negative 1 less than or equal to x, which is less than or equal to 1. And the radius of convergence, again, is half the interval. I'm going from negative 1 to 1. 1 minus negative 1 is 2. Half of 2 is 1. So my radius of convergence would be 1. Okay, so the ones we've done so far were all, we're on an interval and had a radius of convergence. Let's look at some of the weird ones, some of our other cases for power series. So here we got this one, 2 to the x to the 2n over 2n factorial. Again, if I want to see or try to find the interval of convergence, we're going to do the ratio test. All right, so again, when you find the next term, again, you plug in an n plus 1 for the n. I think in this case, when you have like a 2n, it's a little bit weird until you kind of get used to it. But this would be 2 times n plus 1, or this would simplify to 2n plus 2 if you distribute that 2 to the n plus 1. All right, so there's my next term, and then both these I got to do the, our starting term. So I would divide by original series 2x to the 2n over 2n factorial. And when I divide by that, I'm going to flip and multiply. So I'm going to multiply by 2n factorial over 2x to the 2n. All right. And I just brought that down in pink down below here. And now I need again to rewrite this, grouping my n's and grouping the x terms. Looking back here, my work up above as I was doing this, be careful of this. I just noticed I had a mistake technically in my work above. There is a big difference between a 2n 2n parentheses in parentheses factorial, and then the 2n without the parentheses. In the pink up here, this is technically wrong, and I should have parentheses right there. Those mean two totally different things. So just watch out there. All right, so again, simplify factorial. You want to start with the bigger one because every time you're just going to subtract 1, right? So another way for me to write the, this factorial part in front to simplify it would look like this. 2n factorial over 2n plus 2 times 2n plus 1 times 2n. Again, every time just subtracting 1. And now when I get here, I can stop because it's the same on the top and the bottom. So that is how I can reduce and get rid of my factorials. So this limit up above now would simplify to something that looks something like this. The limit as n goes to infinity of 1 over 2n plus 2 times 2n plus 1 times this back part here. You would subtract your exponents, and so I get 2x squared. Now, in this case, again, I really want this to converge when it is less than 1. But in this case, when I do my n goes to infinity, I'm going to get 1 over infinity, which is going to equal 0. So in this case, the infinities don't kill each other off. It doesn't go to 1. It's going to go to 0. So that means it doesn't matter what this x is back here. This limit is going to always equal 0. It doesn't matter what x is. The limit will always equal 0. And since 0 is less than 1, it's always going to converge. Okay. Therefore, the interval is infinite, and this series is going to converge for all x's. Okay. So if the limit equals 0, 0 is less than 1, it'll always converge. Doesn't matter what your x is. And your interval is infinite. And I guess if your interval is infinite, then your radius would also be infinite as well. Okay. This would be, again, an example of what you get if we did the, the power series e to the x. Okay. This exact thing will happen. It would end up being 0. Okay, and our last one here, right? Let's see, again, we want to look for the interval convergence, so we're going to do the ratio test. This time, getting just a little bit lazy. Instead of writing 2 times n plus 1, I just distributed it all at once and wrote 2n plus 2 factorial times x to the 2n plus 2 all over n plus 1 factorial times, I'm going to skip, flip, and multiply, n factorial over 2n factorial x to the 2n. Now I'm going to try to organize my stuff and do some simplifying. So my work would probably look something like that. Again, organizing the 2n factorials in front and then the n factorials after that. And then my x's again in their own separate little area there. Let me leave that so you can see the top there. And now again, I'm going to simplify this factorial business. So I could rewrite 2n plus 2 factorial as 2n plus 2 times 2n plus 1 times 2n factorial. And now I can kill off my 2n factorials. And I could rewrite n plus 1 factorial on the bottom as n plus 1 times n factorial. And so I can kill off the n factorials right there. So the front part would simplify to 2n plus 2 times 2n plus 1 all over n plus 1. And the back part here, if I subtract the exponents, I'm going to get times x squared. All right? And again, we want to now look at the limit as n goes to infinity and see where this is going to be less than 1. But in this case, I'm going to get like 2n squared over n. And so, if we had 2n squared over n, that would reduce to 2n. So this is going to go to infinity no matter what. Again, doesn't matter what x is, this is going to go to infinity. Well, it's going to go to infinity, again, unless x equals 0, right? If x equals 0, then this would equal 0, and then it would converge. So this is the case where it is only going to converge at c. Okay, we said we know all power series converge, have to converge at c, and then that radius might be bigger, or the interval might be bigger, or the interval might be infinite. But we know all power series have to converge at c. So if you get the limit is infinity, then we know it's going to converge only at that point c. So in this case, both the interval and the radius of convergence equal 0. Right? And so that's it today, boys and girls, for 9.AA. Have a good time with it. Enjoy it. Battle with it. If you got questions, come see me, and I'll talk to you all again real soon.